Alright, this is a quick lesson on multiplying radicals. To multiply radicals, the only thing that matters is they have to be the same index. Again, if you remember the square root symbol, this is radicand, and your index is shown right there. When it's square root, we don't show the 2, but it's an implied 2, so usually the square root symbol is just like that. If it was a cube root, we'd put a little 3 there, or fourth root, we'd put a 4 there. You don't have to worry too much about that right now. Everything should be square roots. And so when we multiply them, we like to use the rule outside times outside. And inside times inside. And what that means, if I write some square roots here, let's write 2 root 5. We'll take that times 3 root 6. No, let's do 11. There we go. So I'm multiplying this radical times this radical. Outside times outside means the 2 times the 3. And the inside times inside means root 5 times 11. And that's all there is to it. You'd get 6 root 55. Now the reason this is because this is multiplication, so this is really 2 times root 5 times 3 times root 11. And the commutative property lets us move stuff around as much as we want. So it becomes this, which is 6 root 55. Okay, but it's just outside times outside, inside times inside. And then if we can, we simplify stuff. So for example, 3 root 2 times 5 root 2, outside times outside, 15, inside times inside, 4, but that's just 15 times 2, or 30. And in general, whenever you see the square root of a root 2 times root 2, or a root 3 times root 3, we like to jump to just this, 15 times 2, because this automatically gives you a pair of 2's under the radical, which makes it a perfect square. And you can square root it and just get 2. Okay, now let's look at a little bit tougher one. So I've got 4, oops, look at that. I got 4 root 2 times 3 plus 5 root 6. Now I have to use the distributive property. I have to take this whole term times 3. Okay, the 3, you notice, isn't under a radical. When I multiply it, the 4 is not under a radical, so that's the outside of the radical stuff. And the inside is just a root 2. Now I distribute it to the next term. Outside is the 5 and the 4. Inside is the 2 and the 6. 12 factors a bit, and has a 4 in it, which is a perfect square. The square root of 4 is 2. I multiply it by the stuff on the outside and get 40 root 3. Can't add those because they are not like radicals. And one more big one, let's do 2 plus 3 root 5 times 1 plus 4 root 2. This is a FOIL problem, or a distributive property. 2 times 1. 2 times 4 root 2, outside times outside. 2 is outside, 4 is outside. I distribute the 3 root 5 to the 1. 3 times 1. And I distribute 3 root 5 to the 4 root 2. This is the toughest one for people. 3 and 4 on the outside, and 5 and 2 are on the inside. We multiply them. I check everything to see if I can simplify any radicals. I can't. 10 is made up of 2 times 5. Neither one's a perfect square. None of the radicals are the same, so I can't add them. And so that would be the final answer for this multiplication. And that's it to multiplying them. Outside times outsides, inside times inside, and then simplify.